everybody. My name is Mike, and I'm going to present our case study of recent attempts of productizing of machine learning inside of SAP. I'm responsible for the SAP Innovation Center Network unit here in Israel. I will give a couple of words with respect to SAP. Maybe not all of you are familiar with SAP. And if I would not do this, it would raise a lot of questions why SAP is dealing with machine learning at all, right? SAP is pretty much a big enterprise software vendor. As you can see, during the history, we acquired a lot of businesses on technology and also on enterprise side. Which cover a lot of aspects of processes inside of big enterprises. We have over 300,000 customers in 190 countries, around 80,000 employees. Revenue numbers, as you can see, 44 years of history of innovation, but first and foremost, building solutions for enterprises, right? So SAP is a solution company, and as of today, we see that machine learning technology is evolved to the point where it might be ready for productization in enterprise. And I would like to share with you a couple of experiences on our side. SAP Innovation Center Network is a relatively small organization, so as you noticed, SAP is a big one, 80,000 employees. We are only 500 around the globe. And our target is basically to do this first attempts of productization of recent advancements in machine learning and deep learning as well. We focus on enterprise applications mostly, not consumer, like smart cities, like future enterprise applications. I will explain a couple of use cases further on. We also collaborate closely with academic institutions and with startup ecosystems, but we are not startup accelerator whatsoever. Basically, we collaborate with startups who can contribute maybe to our efforts, and we can somehow join forces to build solutions for enterprises. So when we speak about machine learning, basically we are not limited to traditional SAP data types, which are usually tabular or maybe textual, but we also cover areas in the area of image, video, and audio. This was less common during recent SAP history, but at the moment there are a lot of use cases coming to our table. In terms of our presence around the globe, basically we cover all geographies. We have our major units in Germany. We have unit here in Israel, Southeast Asia, pretty much well covered, and we also have a presence on West Coast in Palo Alto. So basically, we have access to all major technology ecosystems and customers as well. In terms of machine learning and why SAP started to look at it, so it's not a secret, and it's even already hype. Everybody's trying to do something in the area of machine learning. Academy and some of the consumer companies are driving this hype. By demonstrating some really nice use cases and advancements in the areas of autonomous driving cars, in the areas of personal assistance, games, all this kind of stuff. It's more or less clear that this stuff can work somehow, but the question is whether it's ready for prime time and for enterprise. This we'll see in a moment. Also, additional driving factors for adoption in enterprise are better algorithms, are cheaper hardware. As we can see, availability of data, and obviously we sit on a lot of data that currently we can process using recent advancements. We just need to look at the details. Now, as we see, the The digital business, this is how usually we look from our perspective at what's going on in enterprises. Basically, we see main areas around asset management, around workforce engagement, supplier collaboration and business networks. Obviously, we have the biggest business networks in the world with different problems over there, and customer experience over omnichannel. And therefore, our first use cases where we started to incubate and basically, this was announced during recent Sapphire. We have initial productizations which involve machine learning and deep learning in the areas of invoice matching, sales acceleration, social media analytics as well, smart recruiting. This one is very interesting one. Basically, we run the biggest human capital management network in the world, SuccessFactors, with tens or maybe hundreds of millions of users in this system. And one of the big problems over there is automatic mining of talent, of CVs, of matching of CVs to job postings, etc. So as of today, it's done manually or almost semi-manually. And this process is not scalable and not efficient. So we started to invest in this area, and initial results look very, very promising. Recent advancements in natural language processing, recurrent neural nets, Stanford NLP demonstrated that basically it's applicable and can be used. And we started to do some stuff in the area of computer vision and image processing with some use cases in the area of social media analytics like brand logo detection. Now, in terms of architecture, I will do a close-up a little bit later, but in general, we have technical services and business services powering our applications. We have training infrastructure, and everything runs on top of standard stack like Cloud Foundry and underlying whatever container infrastructure and specialized hardware. Also, as I mentioned, we already identified many use cases. Some of them are on the screen at the moment in the area of unstructured, like video and image processing. A lot of these use cases related to common needs, basically to automate manual processes today. So stuff which is done manually by people who identify things, who count things, who read things. Basically, there is a desire to automate all this stuff. Now, I will switch a little bit more to technical details and some recent experiences, and I will start maybe with an overview of how the Census workflow looks. Basically, common underlying pattern is, as you can see on the screen, it starts with data pre-processing and preparation of data sets. Then there is stage of model selection, development, training evaluation, and then we have application, right? So far, pretty much standard, and probably most of you are familiar with that. But then when we start to look closer, basically we discover some things which are kind of unexpected, or maybe there are some misconceptions around it, right? So even though we have a lot of data available, most of the time this data is not labeled, right? And if data is not labeled, then training is not possible, right? So first of all, we need to label data, and for that, in many cases, domain expertise required, right? Like in medical imaging, maybe, or like in agriculture. So not each and every human can do it without specialist training. Also, when we speak about manual labeling, then there are some services who offer this, but the problem with these services, like Amazon Mechanical Turk or others, that the quality of labeling and the quality of data collection is really low, okay, and this is very serious and limiting factor that we already discovered. So before you can even train something and productize something, first of all, you need to solve this problem. And currently, we are working on, in some cases, automatization of generation of these data sets, labeled data sets. In some domains, like computer vision or like voice, it might be possible. In other domains, it is more challenging. challenging. Now, when we speak about model selection and development, exactly, the common underlying pattern is as following. You need to choose the model, so you go to Archive, you read a couple of papers, basically you can find whatever is being published during major conferences over there. And then what next? Next you go and try to find model. If you're lucky, you can find implementation of this model, right? If not, then you have to implement this model by yourself, just from reading the paper and trying to understand what was the architecture of neural net. This is actually experience based on our specific attempt to productize one of the use cases in the area of video processing, right? And then basically you need to invest a lot in DevOps efforts in order to collect, build, compile, and put everything together, because there are no standards. There's no Red Hat or Cloudera or something like that of this world. So basically, yes, there are a lot of tools and the instruments and means for prototyping, but as soon as it comes to productization and enterprise grade quality of the service, we have a problem. Now, next stage is training emulation. So what you discover over there, so let's say you already found the implementation of the model, you managed to collect all the dependencies and it started to run, okay? And you tested it on a small data set and it works. And then you try basically to train this model on a huge data set in order to achieve support for multiple classes, for maybe higher level of accuracy, etc., etc. And then you suddenly discover that training process runs really slow, okay? And then you start to dig into a system and basically monitor what's going on. You discover that basically your training is happening on one GPU and even this GPU is not fully utilized. You try to add more GPUs to the system and then you discover that basically implementation is not scalable. It's not using multiple GPUs, right? This is more or less level of quality of all these open source implementations that you can find wherever on GitHub, right? And when it comes to extending of the model or onboarding of new classes, this becomes a nightmare as well, because as long as your training is not scalable and you cannot accelerate it, then additional of new models or new classes for classification and detection becomes really, really slow and not suitable for enterprise needs, right? Because in enterprise, basically, release cycles are a little bit different than in academic world, right? In academic world, everybody is eager to publish something at CVPR, right? So you have 1 year in order to play with your model on your Titan X underneath your table, right? And then write your paper and publish something to CVPR, go to Vegas. In enterprise, basically the requirements are such that once you demonstrated something which is working, customers are coming and saying, okay, we need to add more classes like in 1 week time frame. Go figure how to do it. So it's not easy, and basically you end up with re-implementing everything. I will speak about this in a second. And same holds true for basic accuracy. So it's fairly easy to get to the point where accuracy is around 80–85%, which is pretty nice for academic papers, and maybe you improve it by 1 or 2% and you can publish something new. Really cool. In enterprise, not enough. 85% in many use cases is definitely not enough, and we need to take it higher and farther, and then basically a lot of tuning and manipulations with the data required. And at the end, basically we come to the last stage when we have our application and we have model, and let's say we have already sufficient accuracy and everything is well, and then we discover that inference is very slow, right? And it's kind of a problem as well. Why? Because inference, when it's slow, it takes a lot of CPU cycles. It costs a lot of money, right? And if our business model is to charge for API calls and inference is slow, then basically we cannot extract any revenue out of it, not to speak about use cases when real-time processing is required, right? And at the end, basically, you end up by re-implementing everything. So our like main takeaway out of all these exercises is that probably development and runtime costs are way higher than it may be initially expected due to a lot of different skill sets which required beyond simple training and optimization of the model. One additional stuff that this cheap GPU hardware, which is available for experiments and prototyping, is totally not suitable for enterprise use cases where you need to run 24/7, because in such situations, basically, we already verified that you can burn these cards pretty much quickly, and then you end up by multiplying your investments like 4 or 5 times because the price differences between these cards that you use for prototyping and for enterprise are 5 orders of magnitude or something like that. And it's inevitable if you want to run 24/7. Same holds true for cloud management infrastructure and scale out. Basically, if there's a need to scale out these solutions, then the whole area around management of multiple boxes with multiple GPUs is kind of not stable yet, and there are no standard solutions for that. And as we already mentioned, open source models, which everybody like to use instead of building their own ones, are really nice for prototyping, but not more. What else? As we envision the emerging infrastructure, basically SAP is not an infrastructure company. This means that we have our own data centers, but we also happily run on non-SAP infrastructure, which is available, and we provide full stack, including our traditional business applications and some upcoming stuff that is needed for running machine learning and deep learning based applications. So it's sort of emerging infrastructure as we see it. Most probably we will offer this to customers at the end of this year or during the next year. So I guess I'm done. If there are any questions.